Hello everybody and welcome to another Bowtie Teacher video. Today was the 1HR IGCSE maths exam and I hope for you that went really well. What I'm going to do today is to predict what's going to come up in the paper 2HR, because if you look at my last video that I did on my predictions, it turned out that most of those came up in the right place as predicted. So I was really pleased with that and I hope that was helpful for you too. Today we're going to look at the things that didn't come up in this paper that are very likely to come up in the paper 2HR. That being said, there are things that will overlap, so make sure that you're studying all of the things as best you can and refer back to the videos and your revision so that you have the best possible opportunity for the next paper. Over the next couple of days I'll be doing a mark scheme to go with the paper 1HR so that you can see a rough estimate of your current situation and you can tally that up against the percentages that usually come up. So with that in mind, let's get started. So what I've tried to do is to arrange these topics in order of difficulty, starting with the easiest and working our way to the more difficult ones towards the end, and I'll try and put timestamps in the description so that you can skip to the ones that you feel that you need the most. Okay, but try and watch as many as you can to make sure that you're picking up some hints and tips and some calculator use that's going to support you in your paper 2. So, standard form then. What we can do with standard form is to try to make sure that we are able to convert between normal numbers and standard form. So if we have something like 84,000 and it asks us to put it into standard form, then our initial number needs to be between 1 and 10. So 1 and 10, and then it's going to be times 10 to the power of something here. Okay, so we look at 84,000 and we put the decimal place somewhere that will make that number between 1 and 10. So if we put the decimal between the 8 and the 4, then we'll get 8.4. And then we have to decide how many spaces the decimal place moved to get to the end of 84,000. So if we have it there, we're going to go 1, 2, 3, 4 spaces to the right, so that's going to be 10 to the 4. And remember, the calculator can do this for us if we go to Shift, Setup, Number Format, and Scientific Mode number 2, and we can just put a number 5 in here for the number of digits that we want. So 84,000, that will be 8.4 times 10 to the 4. If we have 1,200,000, 1.2 times 10 to the power of 6. And if we want to do 0.000357, then that will change it to 3.57 times 10 to the minus 4 for us as well. So when we're doing decimals, then the power will become a negative as we're moving to the left. Okay, that's the basics there. But what we're more likely to be struggling with is the harder ones, where we have something like 25 times 10 to the 16n. Let's call that p. Okay, so in the exam it gives you this 25 times 10 to the 16n, and it says, well, what's going to be p to the 3 over 2? What's the value of p to the power of 3 over 2? And students see this and they get confused. So my advice to you on this one is to have a look at this as if it was 25 times 10 to the power of 16, and you had to raise that to the power of 3 over 2. What would you do then? Well, you'd probably separate this into 25 to the power of 3 over 2 and 10 to the power of 16 to the power of 3 over 2. Okay, and then you would do 25 to the power of 3 over 2 on your calculator, and that gives you 125. And 10 to the 16, well, we multiply these powers, so 16 times 3 over 2 is 24. Okay, so when we get to this stage, we're thinking, well, we had an n in there. The only thing that's going to do is actually put an n here, 16n times 3 over 2. That gives us 24n. All right. Now, this isn't in standard form at the moment because we've got 125. So if that n wasn't there, let's pretend that n wasn't there, then we would do 1.25 times 10. So 1.25 to make that in between 1 and 10, and we'd increase the power by 2. So that would be 26. But if we've got 24n and we add 2 to that, we don't get 26n, we just get 24n plus 2. Alright, so with the easier standard form ones, You can use your calculator to convert to normal numbers and then do the normal calculations. There's nothing wrong with that in the GCSE at all. With the more difficult ones, just try to split it into its component parts. We've got the number, we raise that to the power, and we've got some algebra, we raise that to the power as well. The next topic that didn't come up this time was compound interest. So with compound interest, we're using our formula, which is the amount that we invest. We multiply it by 1 plus the percentage as a decimal, and we raise it to the power of the number of years. Okay, so that's the formula that we can use. So let's say we invest £150,000, and that's going to be at a rate of 6% per annum. Then what we would do is we take our investment of 150,000, multiply it by 1 plus 6% as a decimal, so just 6 over 100, and let's invest it for 4 years. Then we would raise that to the power of 4. If it was 3 years, a 3 would go there. So our calculator, we can just use that to input this. So 150,000 times 1 plus 6 over 100, and we raise that to the power of the number of years. So that will give us the answer directly. We need to make sure that we've come out of fixed mode, so shift, set up, number format, go to number 3 for normal and just number 1, and we get 189,000, etc. So we use this formula to give you the compound interest, but just be careful because sometimes the question asks you just for the interest. Okay, so in that case we would subtract our initial investment, and that's the interest that we've earned, or it might say round it to the nearest, and we just have to make sure that we do that as well. Okay, so when there's a compound interest and the value is going up, then we do 1 plus. If it was something like a car losing value every year, they might talk about depreciation, and then in that case we would do 1 minus the percentage. So if it goes down by 6%, then you do 1 minus the 6% in the brackets there. Alright. Another trick you can use on the calculator, 150,000, press equals, and then we take the answer and we're going to multiply it by 1 plus 6%, 1.06, and then we just press equals the number of times, the number of years that we have. So the first year, second year, third year, and fourth year. Okay, so we're just pressing equals every time the year passes, if you like. In paper 1HR there was some equation of a straight line questions, but from my previous analysis it tends to come up across both the papers. So just as a recap of this, equation of a straight line, we always have to get it in the form of y equals mx plus c, and m is the gradient and c is the y-intercept. Okay, so the y-intercept is the number that's left over from the x. So if we have an equation like 3y equals 9x plus 12, then we have to divide everything by 3 to try and get it in the form of y equals mx plus c. So we get y equals 3x plus 4. In this case, the gradient would be 3 and the y-intercept would be 4. So we can sketch this line, and that would go through plus 4 and have a gradient of 3. So it goes through 4 and has a gradient of 3. What they would usually do then is say, right, we could have a parallel line to this which goes through a certain point. So let's say the parallel line goes through the point 1, 10. Then in that case, what we would do is the equation of the new line would be y equals mx plus c again, but because it's parallel, it would have the same gradient. So in this case, the gradient was 3, so we can rewrite this as y equals 3x plus c. So we know it's parallel to this, but we don't know where it crosses the axis until we substitute in our x and y from this bit of information here. So when y is 10, x is 1. So we can work out our new c value of 7. So the equation of the parallel line would be y equals 3x plus 7. So it would go a bit higher than this one, and it goes through 1, 10, something like this, 1, 10. But this is very rare. It's more likely that they're going to ask you about the perpendicular line. So the perpendicular line and let's say that goes through the point 4, negative 5. So the perpendicular line goes through that point there. So if we think about a perpendicular line to this initial orange one, it could go through here, or it could go through here, or it could go through here. We don't know where it would go until we have that anchor point of 4 minus 5. We also need to know the gradient of the perpendicular line. So the gradient of the orange line was 3, and we multiply it by the perpendicular gradient, and it gives us minus 1. So the gradient of the second line is minus 1/3. If you ever have to prove that two lines are perpendicular, you simply multiply their two gradients together and you get negative 1. So now that we have this new line, this purple line, we know its gradient is minus 1/3 x, and we need to anchor it to its y-intercept. So we're going to find the new c. We substitute in from here, so negative 5 equals minus 1/3, x is 4, plus c, and we rearrange this to get minus 5 plus 4/3. Okay, so minus 5 plus 4/3 would give us minus 11/3. Okay, so we finally rewrite this equation as y equals minus 1/3 x minus 11/3. The question will then do something like write your equation in the form of ax plus by plus c equals 0, where a, b, and c are integers. So at the moment we've got the y first and then we've got the equals, so we're going to rearrange this to put the x first. So we're going to have plus 1/3 x plus y, and we're going to bring the minus 11/3 over to make plus 11/3 equals 0. But a, b, and c are not all integers, so we're going to multiply through by 3 to clear that fraction, and we'll have x plus 3y plus 11 equals 0. Okay, so I just wanted to go over equations of a straight line again, because sometimes they throw in these questions. It says like, here's a line, what's its equation? So you need to know its y-intercept to give you your c value, and work out the gradient to give you m, and substitute it into y equals mx plus c. The next topic is frequency tables, and from here we often have to calculate the mean, the median, or the mode. So the modal one is just you look for the highest frequency and you always look across into the first column and make sure that you don't put 12 down, for example, as the mode. It's always the first column that you refer to. But the more difficult one is finding the mean and the median. So when you work out the median, and this is something that students find a little bit difficult, is that you have to add up the frequency and get your total, and then you have to add 1 to it and then divide by 2. Okay, so if you think about, like, if you have 4 fingers and you want to find the midpoint of those, you don't do 4 divided by 2 because that's the second value. You do 4 plus 1 divided by 2, and that gives you 2.5. So it's halfway between the second and the third value. If you have an odd number, 5 plus 1 divided by 2 is 3, so that always gives you the middle value. Okay, sorry for sticking my fingers up at you there. So in this case, we've got 5 plus 8 plus 6. Let's put this all in. So 5 plus 8 plus 6 plus 4 plus 5 plus 7 is equal to 35. So the total frequency is 35. So the middle value is going to be in the 35th plus 1 over 2, the 18th position. Okay, remember that this is going to be number of dice and frequency, so it's going to be 1, 1, 1, 1, 1, then there's 8 2s, and then there's 6 3s like this, and we're trying to find the 18th position. So you've got 5 plus 8 is 13, plus another 6 is 19, so it's actually this 3 here. Okay, but you don't want to write these all out in the exam, you just want to do a sort of cumulative frequency of these and go 5, 13, 19, so it's going to be in this group here. In this case, the median is going to be a 3. If you want to find out the mean, you need another column here, which is f times x, and x is the first column. So you do your f times x and you multiply these out and you get these, and then you add those all together. So we're going to do 5 plus 16 plus 18 plus another 16, a 25 and a 42, and you get 122. So our mean value is going to be 122 over 35. So we divide that by 35 and we get 3.49. So our mean value would be 3.49 to 3SF for this particular data set. When you have a grouped frequency, we have to do a bit more with this one, okay? Because the heights of these first 6 are somewhere between 0 and 10, we have no idea what those particular values are going to be. It could be 0, 0, 6 zeros, it could be 6 ones, it could be anything in between. So when we're doing these ones, we have to estimate by using the midpoint. We always just take the midpoint, and therefore it's an estimate because we don't know what the exact data values are. So we have to check with these because sometimes they're a little bit sneaky, like 0 to 10, 10 to 20, and we think, all right, it's going up in tens, but then we've got 20 to 40. So always check each of these. 40 to 70, so that's going to be 55, and 70 to 100 is going to be 85. And then once we've done that, we can actually work out the f times x. So this is the new x now that we've worked out the midpoint, and this is our frequency. So you do the exact same thing, add up the frequencies, add up the f times x column, and you divide those two. If you want to find the median, then again we have our frequency here, so 16, 28, 35, okay, and we're looking for the 35 plus 1 over 2, which is the 18th position again. So we go 6, 16, 28, so it's going to be somewhere in that group there. We don't know exactly what it is, so we can only put the class, the whole 20 to h to 40 bit, as our answer for the median. With inequalities, we start from the basics where we have a number line and it's got 1, 2, 3 like this, and it might have an open circle and an arrow. So we'd say x is greater than 1, or if it has a filled circle and it goes down, x is less than or equal to 4. Or it might have a combination of these. Let's say it's a line between these two and just two arrows pointing at each other, then we're going to have 1 is less than x, less than or equal to 4. If you have to solve any equations, like 3x plus 2 is less than or equal to 10, let's choose a better, let's do 11. Then we treat that inequality sign as an equals, but don't actually write equals, because if you take that equals in its place, you actually lose marks. But we just pretend like it is. So we rearrange this to get 11 minus 2. So x is less than or equal to 9 over 3, like that. Okay? You just treat it as a normal equation. Don't flip the signs around. Keep the signs pointing in the same direction. Sometimes they'll do things where you have like a 2 is less than or equal to x plus 3. Let's put a 4x there. Less than or equal to 20. And it asks you to solve these. So we can just treat these separately. So if I ignore this right hand one here and I've just got the 2 less than or equal to 4x plus 3, I'm going to add, I'm going to subtract 3 from both sides. And I can actually do it to this one as well. So I get negative 1 is less than or equal to 4x less than or equal to 17. And then I divide everything by 4, like that. And I have minus a quarter less than or equal to x less than or equal to 17 over 4. Okay, so if you have these double inequalities like this, then you can just treat that as equations separately. Then what we have to do is we have to shade these on a graph. So if we have an equation like y is equal to 2x plus 1, and it says shade the region where y is less than or equal to that, then our y values have to be less than or equal to what it was originally. So if you take a particular value for x and let's call that 2, and this one here is 2x plus 1, that's 5. So this is 2, 5, this particular point here, 2, 5. Then if you choose a y value that's less than or equal to 5, like 4, 3, 2, like this, and it can go underneath the graph as well, then you can see that we start to shade everything that's underneath the line. So here is 1, and that would go to 2x plus 1 is 3. So 1, 3, so 1, 2, 1, 1, 1, 0, 1, minus 1, and we're starting to shade everything under this line. If you have a vertical line like this, and it goes through 2, and we start to shade to the left, then our x is less than or equal to 2, and if we shade the right side, then our x would be greater than or equal to 2. And finally, if we have a horizontal line, let's say here, and that goes through 4, if you want your y to be less than or equal to 4, then you would shade underneath, like 3, 2, 1, and it goes all the way down. Or you can have y is greater than or equal to 4, and you would shade above the line. Okay? And all the exam does is put these together into separate graphs that you have to try and decipher where the regions are. So you do combinations of these in your exam. The next level up for these is to have quadratic inequalities. So if we have something like x squared minus 4x minus 5 is greater than or equal to 0, then what we would do with this is treat that as if it was a 0. We would solve this. So we have x, and we would have 5 and 1, and we need to make negative 4. So we're going to go minus 5 and plus 1. So our x values of this graph would be negative 1 or x equals 5. And we'll just do a quick sketch of that graph going through negative 1 and 5. So it looks something like that. And we want to know where the y value, because this represents the y, where is the y greater than or equal to 0? So we would look at this and we would see our y values are greater than or equal to 0 as you go sort of this side here and here. So you can imagine if x is 6 or 7 or 8, so x would be greater than or equal to 5 here, and x is less than or equal to negative 1. So if you go minus 2, it's going to be up there, minus 3 would be up here, and you're above the line here, the x-axis, where y equals 0. If it was the other way round, and it was less than or equal to 0, then we would be looking at the area of the graph that is underneath the x-axis. So between negative 1 and 5. So if it's ever between, then we would write it in this form. And if it's either less than or equal to minus 1 or greater than 5, we have to actually separate that out into two different expressions here. So if you want, you can go to the quadratic inequality function, and let's do the initial one that we had in purple, which would be number 3, and we had x squared, negative 4, and negative 5. And it tells you here we've got less than or equal to negative 1, comma, so it's telling you to separate that out. X is greater than or equal to 5 if you read it backwards there. If I switch the sign around and I have the less than or equal to, so that would be number 4, and I use the same values, you can see it has that as one single inequality like I have down here. Okay, so use your calculator to help you with quadratic inequalities, but obviously you can't just put the answer, you have to solve it, do a sketch, and then you can put the answer after that. Okay, so when we have to complete the square, first thing we need to know is what does that actually do for us? Completing the square tells us the exact point where a graph has its minimum of a quadratic. Okay, so if we complete the square, it actually tells us that coordinate there. Okay, so what we do is we take an equation, let's say x squared plus 4x plus 6. And let's leave the equals for now. What we do is, when it's in this form with a single 1 in front of the x squared, which we don't ever see, but if that's there, then we take the x, and then the sign here is the same, and the 4, we half it to a 2. We always half, if this is ax squared and bx and c, then b is always halved. Okay? So we do x plus 2 in brackets and we square it. Now if I do this to the side, x plus 2 squared, and we multiply it out, we get x squared plus 2x plus 2x plus 4, which is x squared plus 4x, which is what we actually wanted. But because we've squared it, we've actually got this extra plus 4 that we didn't want. So whenever we complete the square, we just subtract. We always subtract, even if it's a minus in there, we always subtract 2 squared. Whatever that number is, we always subtract it squared. That's the whole completing the square bit, because we've now, by subtracting that, we've completed it, we've made it, we've balanced it out. But we still have this plus 6 here that we've got to deal with. So the final answer of this is x plus 2 squared minus 4 plus 6 is going to be plus 2. So how does that tell us where this coordinate of our vertex is, the minimum point here? We look at the plus 2, and that is the y coordinate. And then we look at the plus 2 here, and it's always the opposite sign to that number. So in this case, it's going to be negative 2. So the x coordinate is negative 2, and the y coordinate is plus 2. So that is the exact point of the turning point of the graph, if you like, where it goes from down to back up again. So this graph would do something like that, and it would go through that point there, 6. So completing the square actually gives us the turning point of the graph, and it also gives us another way of solving an equation. Okay, so we can solve an equation using completing the square, although we often don't do it. We use the formula or we factorize it. So if I take an equation which you can actually factorize, like x squared plus 6x plus 5, and I complete the square, so we're going to do x plus half the b all squared, subtract b squared plus 5 equals 0. Then we get x plus 3 all squared minus 9 plus 5 is negative 4 equals 0. So the turning point of this graph will be negative 3, because it's the opposite of the x, the bracket within the x, and then the minus 4 will be the actual y coordinate. But we can solve this. If I take the minus 4 across and make it plus 4, x plus 3 squared, I can then square root it, so x plus 3 equals plus minus 2, and then subtract 3 from both sides, I get minus 3 plus or minus 2. So my two x values are minus 3 plus 2, which is negative 1, and minus 3 minus 2, which is minus 5, which I would get if I actually factored this to x plus 1, x plus 5 equals 0. So you can see that factorizing it is much more efficient in this case than completing the square. But if you have to, the exam will ask you to leave it in the form like here. This is in the form of x plus a number squared plus another number. Okay, so it's actually telling you the form that it wants it in, and as soon as you see this weird plus p squared plus another number, that's telling you that you've got to complete the square. Okay, now what we have to do for the higher levels is to deal with what happens if I have 2x squared plus 12x plus 9. Okay, because I have to have it in the x squared as opposed to the 2x squared. So I have to factor out a 2 from everything first. Whatever's in front of the x squared, I take that out as a factor. That's including if it's minus, I take that out as a factor, or if it's just minus 1, as in minus x squared, then I take the minus out as a factor as well. So I'm taking the 2 out as a factor, and I'm getting 6x plus 9 divided by 2, that's 4.5. And now that I've done the factorizing, or the factoring of the 2, I can actually complete the square on the thing inside the big brackets. So I'm just going to pretend that that's not there. I'm going to start with the x squared and just do the x plus 3, because I'm halving that, minus 3 squared plus the 4.5. Okay, so I've got my 2 big brackets, x plus 3 squared, minus 9 plus 4.5 is just going to be minus 4.5. And then I can distribute the 2 and get my x plus 3 squared, and then the 2 times the minus 4.5 is minus 9. Okay, so let's check that on the calculator. We're going to go to menu, down to the equation function, and then we're going to do polynomial degree 2, and we're going to put in 2x squared, 12x, and 9. Okay, now your calculator, we're not interested in solving this because it hasn't got an equal 0 there, but if you keep going down, it actually tells you the minimum of this. So it's actually looking for the minimum, and the x coordinate is negative 3, so it's going to be the opposite to the bracket, which is plus 3, and I go down one more, and I get negative 9 for the y coordinate, which is the minus 9 here. So your calculator can actually complete the square for you, but just make sure that you actually go through the steps and don't just put the answer down. So what do we do if we have something strange like this, where we've got it all in the wrong order and we've got a minus 2 in front of the x squared? What I tend to do is to write this in the form of ax squared plus bx plus c. So I'm just going to rewrite this in a kind of normal quadratic that I'm used to. And bear in mind that a negative x squared is going to be upside down like this. So we're actually looking at the maximum point here. And I do the same thing. Once I understand I'm taking this minus 2 out as a factor, then this is going to become x squared. This will become negative 6x, because when I times it by minus 2 I get plus 12, and I want a minus 2 here, so it's times by minus 2 to get 4. And I just go through the same process again. I can now complete the square on this, minus my 3 squared and minus my 2, and I get x minus 3 squared minus 9 minus 2 is minus 11. Minus 2. Now, sorry, before we do that, they usually write this one in the form of like c minus b brackets x plus a squared, or something like that. These signs could be different to what's actually in the answer. So we've got minus 2 brackets x minus 3 all squared, and then minus 2 times minus 11 is plus 22. So we're actually just going to rewrite this so the constant term is going to be at the front, minus 2 brackets x minus 3 squared. Okay, so this completed square form is telling you how they want it to be written for your answer. Simultaneous equations came up in paper 1HR, but you might not have realized it where it had the graph and it has the line that crosses and things like that. You can actually use simultaneous equations to do that, but it's kind of hidden deep down. So I predict that simultaneous equations will come up again, especially the quadratic ones. So let's go over what simultaneous equations actually do for us, and that is that they give us the point at which two graphs intersect. Okay, they cross over here, and that will have an x coordinate and it will have a y coordinate as well. So that is the exact point where both of them have the same value. Both graphs have an x and y of the same value, and it's used to tell us when we have two unknowns, we can then try to solve it, but we need two bits of information, two equations usually, that will help us to solve it. So the basic ones are the two linear terms which we have here, two linear equations, 5x plus 2y equals 13, 3x minus 7y equals 16. And students would like to usually double one of these or triple it or something like that, so you get your terms the same. So in this first case, I've got 5x and 3x. Well, if I cross multiply these, like I multiply the other one by 5 and the first one by 3, then that will give me two terms in x that are exactly the same. So I'm going to times this by 3 and times this one by 5, and I get 15x. I times everything by 3, so I get plus 6y, and I get 39, like that. The second equation, I times by 5 to get 15x minus 35y equals 80. Now I have two terms the same in x, and they both had the same sign in front. So if they had the same sign, we subtract them. Okay, so I do the first equation. It doesn't actually matter which way around. I'm going to do the first equation. So let's call that equation number 1, and this is equation number 2. I'm going to do 1 minus 2. That will give me 6y. So 15x minus 15x, that will cancel out to give you 0. We have 6y minus negative 35y, because I'm subtracting them, but I'm also subtracting a negative there, and I get 39 minus 80. So 6y minus 35y is 41y, and 39 minus 80 is minus 41. So my y value is minus 1 when I divide. Once I have my y, I substitute into x, and either of these equations, and I will find out my x. So I'm going to go into the first equation here. 5x plus 2 lots of y equals 13. 5x equals 15, so x equals 3. Get my two coordinates there. So 3 comma minus 1 is where those two graphs intersect. I use my calculator to do simultaneous equation. If I go to the equation function, simultaneous equations, and for GCSE we've got two unknowns, x and y. So we've got the original was 5x, 2y, and 13, 3x, negative 7y, and 16. Press equals one more time, we get x equals 3, and y equals negative 1. So the calculator can help us as we go to the latter stages when we have series and sequences. This x, that might be an a, the y might be the d for common difference, and then we have a number. So just in your mind think, well, I'll just make sure that x is an a and a d is a y on my calculator when I check it. The next one is when we have a linear equation and we're substituting it into a quadratic, because when you have a curve like this and we have something that crosses through it like a line, it gives us two intersection points. So we now have two x comma y's. Okay, we get two solutions to this. How do we do it? Well, we take the linear term, the linear equation, and substitute it into the quadratic. So I'm going to choose x equals 7 minus y, and I'm going to substitute that into this equation. I could have done y equals 7 minus x, that will work too. It just looks a little bit more easy to substitute for x in this case. So I'm going to do 7 minus y squared. I've substituted for x and I put that in here. Plus my 3y squared equals 79. I'm going to expand 7 minus y squared. So 7 minus y, 7 minus y. And that's going to give me 49 minus 7y minus 7y plus y squared. That's that bit done. And now I can add my 3y squared and equal 79. And I'm going to rearrange this to get a quadratic in terms of y. So y squared plus 3y squared minus 14y, and 49, I'm going to bring the 79 across by subtracting by 79, and I get minus 30. Okay. On our calculator we can put this in to our polynomial function, and we get 4, negative 14, and negative 30, and that gives us our two values of 5 and minus 3 over 2. So y equals 5 and y equals minus 3 over 2. In the exam you won't be able to just put those in there, so we will cancel through by 2 to get 2, minus 7 and minus 15, like that. And we know our brackets are going to be, we've got y equals 5, so we're going to have y minus 5. And so to get 2y, I'm going to do 2y, and to get the 15, I'm going to have positive 3. So just check that, 2y squared plus 3y minus 10y, negative 7y, that works. So my y coordinates are y equals 5 and y equals minus 3 over 2. I then substitute back into our x in the linear to make sure that I get my x coordinates. So when y equals 5, 7 minus y is x equals 2. And when y is minus 3 over 2, 7 minus minus 3 over 2 is going to be 8.5, I think, like that. So these are the two pairs of coordinates where these particular graphs overlap. The next topic is algebraic fractions. So with algebraic fractions, we need to be able to add these things together, subtract them, multiply, divide them, and simplify them. So the first one I've got here is 7 over x plus 3 over x plus 1 is equal to 29 over 24. So when we're adding fractions, we need to make sure we have a common denominator. And if this was like 7 over 20, for example, plus 3 over 21, how would we get a common denominator with these? What we would usually do is do 20 times 21 on the bottom, and we would cross multiply these so that we can add them together. We'd do something like 7 times 21, and we'd add that to 3 times 20. Okay? So we're going to do exactly the same thing with the algebra. 7 over x plus 3 over x plus 1. What I'm going to do is I'm going to multiply the two denominators to get x brackets x plus 1. And then I'm going to do a cross multiplying here. So let's put this underneath actually. We're going to do 7. I'm going to cross this and multiply it by that. 7 brackets x plus 1. And I'm going to cross this one to do 3x. Okay? This is all over a common denominator of x brackets x plus 1. And our original equation was that it equals 29 over 24. But that's kind of a bit more in depth. Let's just simplify this a little bit more. We've got 7x plus 7, when I open this out, plus the 3x is 10x plus 7 over x squared plus x. You can leave it as a factored version if you like. So we're starting to add these together by cross multiplying and then doing the two denominators multiplied by each other. Okay? So we can now solve that equation if we want to by multiplying both sides by the denominator and then rearranging it like that in a normal way. But adding these things together is something that students find a little bit difficult. Let's do some multiplying. Let's go to the bottom and actually multiply these two. Then we can, if we want to, down here, let's just do top times top like we do with any fraction. We have 5x brackets x plus 2. And on the denominator, we have x brackets 6x plus 12. Okay? So we can cancel the x's here because we have an x in the top and the bottom. And then we have 5 brackets x plus 2 over 6x plus 12. I can factor that to 6 brackets x plus 2. So we have a brackets in the numerator and the denominator we can cancel, and we're left with 5 over 6. Okay? But when we're multiplying two fractions together, we can actually cross cancel. So I'm looking here at x and the 5x here, and I see that there's an x in both, so I'm going to cancel that to get a 1 and cancel that here. The denominator, I can see I've got an x plus 2 and a 6 brackets x plus 2. So I can cross cancel this x plus 2 to make it a 1 and x plus 2 to cancel that to a 1 as well. So on the top now I have, it looks a bit messy, but 1 times 5, and on the bottom 1 times 6. Okay? The one in the middle here is a simplifying of algebraic fraction, and I've done a video on this before, but if you haven't seen this, we're looking for factorizing these brackets, and also we're looking out for difference of two squares. So the denominator is a difference of two square numbers. It's 2x all squared and 7 squared. So we're going to have 2x plus 7 and 2x minus 7. Okay, you can check that for yourself if you want, and we can also, let's do another one of these, 4x squared, 0x and negative 49. So we get 7 over 2 and minus 7 over 2, which you can back to the brackets of 2x plus 7. On the numerator, we've got 2x squared plus 13x plus 21. Well, it's very likely that one of these brackets is going to be 2x and 7. We're not sure if it's going to be plus or minus, so we'll just leave that for now. To make 2x squared, I need to multiply it by x, and to get 21, I need to multiply it by 3, and it's plus and plus, so it's just going to be plus and plus like that. Double check that one if you need to. And when we have a bracket in the numerator and denominator again, we can cancel, and we're left with x plus 3 over 2x minus 7. Okay, so these more difficult algebraic fractions are going to be a variant on one of these skills. Proportion is something that students find a little bit difficult. If we take a step back and we look at two variables like x and y, and there's some sort of relationship between them, like a straight line relationship, then y is proportional to x. Okay, they're related somehow, and in this particular instance, the relationship between them is the gradient of that line. Okay, so when we're looking at these, we can actually replace that proportional sign with an equals k. Alright, so we've just replaced that proportion sign with equals k, and then we multiply it by the x that we have there. So we can see there we have an equation of a straight line, and the relationship between them is the gradient. So this is simple proportion, and we use that to convert things like dollars to pounds, or we might convert miles to kilometers and things like that. These are a proportional relationship with a constant term between them. Sometimes the relationship between y and x might be a square relationship, or a cubic relationship, or a square root, or maybe a 1 over x. So we have to look at the question and decide what proportion we're looking at. So if in the question it says that y is proportional to the square of x, then we say y is proportional to x squared, and we just change that to equals kx squared. If y is proportional to the cube of x, then we write it like that, kx cubed. Sometimes they will have y proportional to the square root of x, so we just have to be careful which one we're looking at. And then in some cases we have y is proportional to 1 over x. Okay, so 1 over x, we call that an inverse proportion. So if they mention the word inverse proportion, then it will be proportional to 1 over. So it might say it's inversely proportional to the square of x, so 1 over x squared, or it's inversely proportional to the square root of x, so it's 1 over. Okay, and in this case we don't just do equals k, we make it y is proportional to, y is equal to k over x, or k over root x, or k over x squared. Okay, so inverse proportion we do 1 over, and then from the question we just have to get the information that we need. It will say something like x is 10 when y equals 40, or something like that, and we substitute those values into this equation to find k. Alright, so if we have a look at y equals kx squared, and we get y is 40 when x is 10, so it's going to be k lots of 10 squared, then k is 40 over 100, or k equals 2/5. Alright, so when k is 2/5, we rewrite this equation one more time, y equals k 2/5 and then x squared. So they usually ask for the formula of y and x and how they're related to each other, which in this case is 2/5. Part B will usually just be taking a different set of values and finding out the other one. So they might say, for example, if x is 4, what is y? And you just substitute into that, rearrange it, and find what you're looking for. But the difficult bit is getting started with this proportion business. So decide which relationship you have, change it to equals k, find k, rewrite the equation with k now that you've found it, and then that will be part A over. Part B will just be finding that out from a rearranged version. Circle theorems has come up in paper 1HR a little bit, but they had a very straightforward one, which was something like, I haven't seen the paper yet, but my students have told me that it was something like this, and it had an angle there, and you had to find out something like in here. So that one's a relatively straightforward circle theorem. So just to recap on the others, we have a circle, and we put a chord in here like that. If we try to make an angle in this chord, in this segment here, this is called a segment. If we make two angles within that same segment, then those two are equal to each other, and also these two are equal to each other as well, because they're in the same segment as well. This is called the major segment. If we have a tangent and it goes to the center, that will form a right angle like this. If we have a tangent like that and we make a chord, let's draw that slightly better, a chord like that which touches both sides, then this segment here, if we put an angle in here, let's say that's 40, then I can make any angle I like, another point on the circle, that will be 40 as well. If I made it up here, that would be 40 as well. You may recognize this sort of shape, all right? But this is called the alternate segment theorem. And that's one Edexcel seem to like to keep asking, because students don't kind of get this. So you're looking for an angle that is in one segment, and it will match the angle in the other segment. We also have this kind of thing where we go to the middle and have the arrowhead shape, which we had in the last one. This is double this one. And we also have the intersecting chords. So we have two chords that intersect like this, and we get this line times this line is equal to this distance times this distance. So if you have two chords that intersect, let's say it's A, B, C, and D, then A times B is equal to C times D. If they intersect outside the circle, so you have your chords and they intersect outside the circle, then in this case what we have is, let's make this A, B, C, and D again, then it's A plus B, and it's, so that total distance multiplied by the one outside the circle, so times that by B, that is equal to C plus D multiplied by what's outside the circle, in this case C. So slightly different formula there when it's intersecting outside the circle. In paper 1HR we had a bit of basic probability, so then in the second paper we're probably going to have some harder probability, and this is kind of like the question that you might come up against. We have 8 red counters in a bag and the rest are green. Probability of choosing 2 greens is 1/5. How many green counters are there? So if you're ever looking at these probability and we're not sure, it's good to just draw a probability tree to see if we can put some information in here. So we have 8 red counters. Let's say red is going to be the top, and then we go green, red, green, like that. So we're going to have red is going to be 8 out of the total, which we don't know what the total is, so let's call the x the total. 8 out of x, and then if I was to go red again, it would be 1 less, and the total would be reduced by 1. Okay, so that would be going red, red, but what about the greens? Because we don't know what greens are. Well, we can express the greens as the total minus the number of reds. So if we had 20 in the bag and 8 were red, then we do 20 minus 8, that would be 12 greens, but we don't know what it is, so we keep it as an algebra term. So green would be x minus 8 over x minus 1, like that. We're not really interested in these ones. We're looking at green. So green was x minus 8 over the total. And then the second green would be one less green in the bag, so x minus 9, and one less of the total. Okay? So the probability of choosing two greens, so green is actually 1/5. They're giving us the probability when they usually ask us to work it out. So we go down these branches here, green, we multiply them, and that equals 1/5. So we've now generated algebraic fractions that we can use to solve this problem. So earlier in the video we did multiplying these, so we're going to do top times top, x minus 8, x minus 9, over x brackets x minus 1 equals 1/5. And we're going to get rid of the denominator by multiplying both sides by x brackets x minus 1, so times 1, and that gets rid of this, and the 5 would be cross multiplied up here to get rid of this. So I'm going to multiply out the brackets and would have x squared minus 9x minus 8x is minus 17x, and then 8 times 9 is plus 72, and that's going to be equal to x squared minus x when I multiply out this bit. 5x squared, 17 times 5 is 85, and 5 times 72 is that 360, plus 360, and then that equals x squared minus x. Take that across to get my equals 0, and I get subtract x squared, and then subtract, I'm going to add an x, so minus 84x plus 360. I think 4 will go into these, x squared minus 21x plus 90 equals 0, and then I can solve this, so I have x squared, negative 21, and 90. So I get x1 equals 15, and x2 equals 6. So my first x value is 15, and the second value is equal to 6. So we've got 2 here, and usually one of those will be a fraction or it'll be a negative, and that's easy to try and ignore. But in this case, both of these answers could be potentially valid. Okay, so we have to think a bit more deeply about, does one of these not make sense? Okay, if we have a total of 6, then 8 of them are red out of a total of 6. That kind of doesn't make sense. If we have a total of 15, then 8 out of 15, yeah, that makes sense. But we can't have 8 red counters out of a total of 6, because remember, we're solving for x, and that's the total. So sometimes we might get 2 answers that are kind of, they seem like they're valid, but we have to double check both of them and make sure that they both fit, and usually, well, one won't. Okay, so you're using your skills with algebraic fractions to try and solve a probability question. Okay, the next topic that I'd like to talk about is vectors, because that didn't come up in paper 1, so it's very likely to come up in paper 2. And I've just drawn a diagram here which will help us to understand some basics about vectors. So if I wanted to go from A to B, they're telling us that that's the vector A, and all of these lines are the same length. So C is going from A to D. So when you're using vectors, if you wanted to go, for example, from A to E, we can't go direct from A to E. We have to use a combination of A's and C's. So if I wanted to go from A to E, I would go either C plus A, or I could go A plus C. Either of those would work. They're both the same thing. And if I wanted to go from D to H, let's say D to H, then I would start from D. I could go A plus C, or I could go C plus A. I could even go A plus C minus A, and that would still give me A plus C. So these two lines, A to E and D to H, are parallel to each other, because if you look at the ratio of A's to C's, the ratio of A's to C's is in a 1-to-1 ratio, and in here they're in a 1-to-1 ratio as well. Okay, if I was to go from A to I, then I would have to go 2 lots of A to get from A to C, and 2 lots of C. So would this be parallel to DH, for example? Well, yes, because they're in a ratio of 2 to 2. But I would take the 2 out as a factor, and then I would have A plus C, just to show that that's in fact a 1-to-1 ratio of A's to C's. Because the number in front is what we call a scalar. So the scalar will increase the size of the vector, okay, but it does nothing to the direction. So we're looking at the ratio of A to C, which will give us the direction, but we're not too worried about the length of these two things. Okay, so if I was to go from A to H, that would be 1A to get from A to B, and 2 lots of C. So now you can see that the ratio of A's to C's is in a 1-to-2 ratio. So these are no longer parallel to each other. So when you're in the exam and it asks you to prove if something's parallel, what you do is try to get the 2 vectors and then factor a number out which will show them to be in the same ratio. Or alternatively, you could be a bit different, but this is helpful for the more difficult questions. I can divide the 2 A's. So in A to E, I've got 1A, and here I've got 1A. So I can do 1A divided by 1A, which is in a ratio of 1-to-1. So for my A component, they're in a ratio, we have a ratio of 1, and if I do the same to C, when I divide them, then I also get a ratio of 1. So these are in the same ratio as each other. If I did the same for the bottom 2, when I had 2A divided by A is equal to 2, and then 2C divided by 2C gives me 1. So they're not the same ratio to each other. That's an advanced concept, but it's one that we used at the end of June 2019, I think it was, when we had to do ratios and have it as a fraction. The only other thing we would have to do is to prove that something's on a straight line. So in order to do that, we do the exact same thing as what we've done before, but we just make sure that one of the points is in common. Now what I mean by that is if, for example, we had to go from A to I and prove that that's a straight line, then we choose a point that's on the line A to I, so that line's going through there, and we want to prove AI is a straight line, and we go A to E and then E to I. So we're going from A to E and E to I. So if we go from A to E and we get A plus C, and we go from E to I, which is also A plus C, then those 2 lines, A to E and E to I, are parallel, but they also have a point in common, which is point E. So if you can imagine 2 parallel lines and they both go through a single point in space, that will bring those 2 separate vectors together to make one straight line. So you're using the same concept of parallel lines, but you need to have a point in common for them to be on the whole straight line. So it's the exact same method, go from A to E, E to I, and then because they both have E in common, then they're in a straight line. Because you can have 2 parallel lines that don't have a point in common in space, but once they do, they line up and make one single straight line. The next topic that's almost certain to come up is sequences. So let's recap on a sequence. From key stage 3, we can go 3, 7, 11, etc. And you had to create a formula for that, which would be finding out the difference between the numbers, which is 4, and then we would just go 4 lots of n, and that would be 4, 8, 12, and then we subtract 1 to get to our 3. All right, but in the GCSE, they don't give you the actual sequence. They'll do something else, and you have to use simultaneous equations to work it out. So the formula that they give you in the front of the test is for the sum of a sequence, which we'll come back to, and it's n over 2 brackets 2a plus n minus 1d. But the formula for the nth term, which we actually need for the first part of the question, is just, if I scrub out everything up to the 2, is this formula here from a to d. So the nth term is a plus n minus 1d. So what that does is that tells us any position. If I choose the third position or the fifth position, that will tell me what that number actually is. So let's check that using our original example. A, which is the first term, so the first term is a, 3, plus n minus 1 lots of d. D is the difference between each number, so we're going to multiply that by 4. So we get 3 plus 4n minus 4, which gives us 4n minus 1. So in the exam, they're more likely to give you something like the third term is 11 and the sum of the first 4 terms is 36. So in this case, we have to try to use these two bits of information with two unknowns to generate simultaneous equations. So the third term is 11, so that's going to be a, which we don't know, plus n minus 1, so n is 3 because it's the third term, multiplied by the common difference, which we don't know. So that's going to be 11 equals a plus 2d, our first simultaneous equation. Then using the sum information, the sum formula, 36 is going to be equal to n over 2, which this is in the front of the test. N over 2 for the 4 terms is 4 over 2, brackets 2a, which we still don't know, plus n minus 1, 4 minus 1 lots of d, which we don't know. So this is a 2, and we divide both sides by 2, and we get 18 equals 2a plus 3d. That's going to be our second simultaneous equation. So we do the normal simultaneous equation stuff, double 1, subtract them, etc., and that will give us our a equals 3 and d equals 4. So that will be the first part of the question, and then the final part will be saying something like, well, find the 20th term. So we're going to do the 20th term is a plus 20 minus 1 lots of the common difference, which is 4, and we work that out, and we have 3 plus 19 times 4 is 76, so that gives us 79. And then we could do something like the sum of the first 10 terms. So we use the sum formula, 10 over 2, brackets 2 lots of a. So a was 3 plus n minus 1 lots of d. We can work all that out on a calculator, and that will be the sum of the first 10 terms. Okay, so the job is to find a and d, and then we use that to find out the second part of the question. The final topic that we're going to talk about is proofs, and that's difficult to talk about really because there's only a couple of things or rules that we can really refer to, but one of those is that we have even numbers such as 2n. We represent any even number by 2n, and then an odd number we would represent as 2n plus 1. So sometimes they say something like, prove that two square numbers are even if they're even to start with. So let's say we have two even numbers, two consecutive even numbers like 2n, that would be the first number, and then the second number would be 2n plus 2, because we'd have the consecutive numbers would be, say, 6, and the next one will be plus 2, that's 8. So we're going to square these and add them together. The proof is, prove that they are an even number. The square of two consecutive numbers is even. So we do all this algebra and we get 4n squared plus 8n plus 4. And to prove that something's even, we take a 2 out as a factor and there'll be no remainders. So whatever's inside this bracket, we'll double it so it'll be even. So we'll collect these together to get 8n squared plus 8n plus 4, and we can take the 2 out as a factor to get 4n squared plus 4n plus 2. Okay, so it doesn't matter what the value for n is, we're going to double it and that will make sure it's an even number. If we were to take two odd numbers and their consecutive squares, so something like 3 squared plus 5 squared, that would also be even. So let's see if we can prove that. We multiply all of this out and we get 4n squared plus 4n plus 1, and then we get 4n squared plus 6n plus 6n is 12n plus 9. Add that together, we get 8n squared plus 16n plus 10, and take 2 out as a factor so that we can prove that that will always be even. No matter what's in that bracket there, it will be even. So that's how we do these proofs. If we were to say, prove that an odd number squared is always odd, then we would take an odd number, which we represent as 2n plus 1, and we square that out, and we get 4n squared plus 4n plus 1. We take 2 out as a factor, and we get 2n squared plus 2n, and we have a remainder of plus 1. So what we have here, whatever value for n is, we're going to double it to make it even, and plus 1, that will always be odd. Okay? So with the proofs, they're the only ones that we can really discuss in the video, but in the GCSE they might come up with something really random to separate the grade 8s and 9s from each other. But if it's anything to do with evens and odds, we're doing combinations like this. Okay guys, so I hope that was helpful. After the success of my predictions for the first paper, these should be relatively accurate, but like I say, they're not for definite, and you should definitely try and study as much as you can in the next week or so that you're fully ready for this test. As you go into the exam, remember there'll be questions that you find difficult and ones that you perhaps can't do. Don't waste any time on those. Just move on to the next question and let your subconscious kind of tick that over, and then something will probably come to you if you remain calm and collected. Okay? Let me know in the comments below how you got on with these tests, and if there's anything that you'd like me to do in the future. Otherwise, good luck, and I wish you all the best.